Welcome to Best Academy TV. In this video, we're gonna focus on advanced questions on dimension, and we're taking question 1 here. That is this. But before we solve this question here, let's understand the question perfectly. They said given that P plus A over V square. Of course, this P here represents pressure. This V here represents volume. Please take notes. The A here is a constant we are asked to calculate. This V here also represents volume. While this B here is a constant, please take notes. This arrow here represents ideal gas constants. This T here represents temperature. So this equation is popular as said. They said the equation is popular, okay, which we know in our chemistry. That is P V is equal to N R T. You can remember that, okay? So it's a popular gas equation, and here we are asked to determine the dimension. Please take note, the dimension of A, that is constants A and B. But before we determine the dimension, please listen to me carefully, okay? The first thing to do is to understand the equation first before we solve the equation. So this equation we are seeing here is a popular equation we know first, but we are asked to find A, B. That means we have to make A the subject, make B the subject. But we don't have to make A the subject in this particular equation here. We are going to know what to do later. So if you make A the subject, make B the subject, the next is to find the dimension of this here. The next is to find the dimension of this here. Please take note. So how do we find the dimension? But before you find the dimension of any quantity, you have to find the unit first, okay? Now let's solve this first to understand the explanation. Let's solve this first to understand the explanation, okay? Solution first. Class, for me to solve this particular stuff here, I will use comparison. So I will compare this with the standard equation of ideal gas law. So the standard equation of ideal gas law is this. We have this to be P V is equal to N R T. This, we can call this equation 1. Please take note. So using this equation here, that is this first equation here, class, to compare with the one given to us here in the question. So doing that, we have something like this. That is P, please take note, P bracket open plus A over V squared, close your bracket, into V minus B is equal to ROT. We can call this equation 2. Please don't be afraid of the equation 2, equation 1. The reason for equation 1, equation 2 is to be specific, okay? So this is our standard. This one here is the standard equation of ideal gas law, while this one here is the given one here, okay? If you look into equation 1 and equation 2, they are looking alike. They are alike, sorry. If you look into equation 1 and equation 2, they are alike. That is, they are like the same, okay? So what am I going to do here? I'll compare equation 1 and equation 2. To make this to be clearer to us here, class, listen to me carefully. This equation 1 here can also be expressed as P bracket open, close your bracket, close your brackets, into V, close your bracket, is equal to N ROT. Class, multiplication in mathematics is certain as open and close brackets. So it means that this one here, this part here, belongs to this. this part here belongs to this, and this part here belongs to this here. So now let's compare. So now in comparison, it means that this part is equal to this. That is the meaning of comparison. While this part is equal to this. That is the meaning of comparison, okay? So when you do that, we will have something like this. When you do that, we will have something like this. That is P is equal to, that is this particular P is equal to the whole of this guy here. Please take note. It's equal to P plus A over V square. Okay, but remember our intention here is to make A the subject. So this is the same thing as P here is equal to this P here, and this P here is equal to this P here. But since our intention here is to find A, we focus on the part of A, okay, is to find the constant, that is A and B. So focus on this part here, that is the part of A. That means this is equal to this here. When you do that, our P, sorry for this, our P is equal to A over B square. Okay, now let's make A the subject of formula here. But don't forget P, this P here represent pressure. This V here represent volume. Please don't forget. So making V the subject of formula, I will cross multiply. When you do that, A, sorry for this. When you do that, A will be equal to plus PV square. And this is pressure in formula is known as force over area times volume V square. The formula for this is this, remember, times V square. So this is the secret of dimension. To find any dimension, to find the dimension of any quantity, the first thing to do is to find the unit. And for us to find any unit, for us to find the unit of any quantity, we have to know the formula. So the formula for pressure is force over area. So of course, we know that force, the formula for force um is mass times acceleration, and the unit of mass is kg. So I will have this to be kg, that is kg meter per second square. That is for this force here. While for area, area is length times breadth, and breadth and length fall under distance. So I'm going to have something like this, over meter times meter. Okay, breadth is meter, length is meter, times volume is meter cube. So this is going to be meter cube or square. The square is as a result of this one here. Please take note. So class, when you simplify this here, we'll have something like this. Please permit me to use the up. Okay, let me clean this part here. Okay, now when you simplify that, we have something like this class. That is A is equal to class kg meter per second square times meter raised to the power of 3 all squared over meter square. Remember, meter times meter is meter square. So using the law of indices, that is this to this, we all know that if I have something like this, a raised to the power of n times a raised to the power of n, I will take one of the base and add up their powers. So that is the first law. Now the second law here is that if I have a raised to the power of n or n, that is power law, I will have this to be a raised to n. So apply the same thing here. I will have something like this. A is equal to kg meter per second square times meter raised to 6 over meter square. So class, this guy will cancel this guy here. I'll be left with m raised to the power of 4 here. So when you do that, I will have this to be kg meter per second square times meter raised to 4 here. Okay, so applying the law of indices here, this is m and this is m, just like this law here. So I will have this to be class kg of n raised to the power of 5 per second square. Please take note. But remember, we are asked to convert this guy here, this a here, as dimension. But before we find any dimension, the first thing we have to do is to express it as unit. So we have expressed this guy here as unit. This is a as unit. So in terms of dimension, we say that dimension is a way of expressing the fundamental quantities in their initial letters. That is mass, the initial letter of mass is m. Length, the initial letter of length is L. Time, the initial letter is T. So that means if I have mass, mass is kg, so the dimension is m. If I have length, length is meter, the dimension is L. If I have time, time is seconds, the dimension is T. So this row here is for units. This row here is for dimension. Please take note. So if that is the case here, let's change from the unit aspect to dimension. So we're going to have a to b. Sorry for this. That means our a will be a is equal to kg. Dimension is this, that is capital letter N. Meter, the dimension is this, that is L raised to the power of 5. Seconds, the dimension is this, that is T raised to the power of -2. So class, this is my A. Our A is M, L raised to the power of 5, T raised to the power of -2. But remember, we are not only asked to find A, the constants A, we are also asked to find the constants B. So how do we find the constants B? Remember, we compared the general gas equation to the given equation. So when you do that again, something like this, we said this equation here, that is P plus A over V squared all times V minus B equal to R root T compared to P V is equal to N R root T. Of course, you can put bracket open here and bracket open here. They are seeing the same. That means this one here is this part, which we have done, and this one here is this part. So that means V is equal to V minus B. So when you do that, our result will be V will be equal to class V minus B. That is this V will be equal to V minus B. But our intention is to calculate or to make B the subject of formula. When you do that, we have something like this. But let's just compare first. When you compare this, that is the second part, we have this to be V is equal to V minus B. Please take note. So this equation simply means that V is equal to this V, or this V is equal to B. Please take note. But our intention is not the V aspect. Our intention is on the B aspect. Please take note. So we'll take this as V is equal to minus B. So making B the subject, please take note of this. The B there is volume. Please take note. Making B the subject, that is B, will be equal to minus V. So finding the unit of this before the dimension, this is the same as n raised power of 3. Remember, volume is the same as length times breadth times height. And these guys here are the fundamental quantity of length. This one can be classified as length, the same thing as breadth as length, height as length. So making this guy here to be in form of dimension. Remember, for dimension, length is meter in unit, but L in dimension. So our B will be equal to minus L raised to 3. So in summary here, in dimension, A is equal to class, A is equal to M, L raised to 5, C raised to minus 2, B is equal to L raised to 3. We don't take the negative here, please take note. We don't take the negative, we only take the positive aspect. So this is our answer here. All right, so all you have to do to get an advanced questions on unit and dimension is to hit the subscriber button, and you get all the questions on dimension and other topics relating to physics 101. Okay, thank you.